Okay. So I didn't get the first ones done just because they always confuse me. And so I skipped the first ones.
Which ones didn't you do? Oh,
The
like the first five?
Yeah, just the multiple choice ones I didn't do. Just through number 8 with the tests and everything.
Can you hear me now?
Okay, there we go.
That's better. All right. Let's see this. So you were saying that you didn't do the first few?
Yeah.
Like number two?
Yep, like
I
number
put
2.
I put H because really I don't know.
Okay. I did do E for number 3. Did you get that?
E?
I put it as an ANOVA just
It could be.
because I read in the reading something about how they needed to be equal, and it said to determine that both were treated equally. So I thought maybe that has something to do with it.
That sounds great to me.
So
Did you put one for four or five?
I didn't.
Okay, so on four, I put G. I don't know.
Tested two proportions.
Yeah, like it splits them up between male and females.
Okay. Okay.
I don't know.
Um, that's okay. That sounds good to me.
For five, this one I wasn't sure if it was like a paired sample, like the difference.
Okay. Um, all right. Sounds good to
Because
me.
I don't know why. No, they were just given different clocks. I thought that they were timed with one clock and then timed with another.
Hmm.
So that one, I don't know.
Maybe an independent
Two different.
sample.
Yeah,
Would
it
they
could be
would they be independent?
kind of.
So they're each given different things.
Like the locks, there's two types of locks. They
Oh,
want
and
to
they
see
want
which
to know
one's
which one was
faster.
easier. Hmm.
I
They
don't
don't
know.
like depend on each other though to like get a result though, right?
No, they don't.
Would it be like I don't know, a test of two proportions?
It
I
could
don't
be.
know. Because it's not one sample because they're taking from I don't know.
I think it could be C or it could be G, because those are the only ones that use like just two. The chi-squared test. What does that one look like? Let me see. That's the one with all the columns.
Yeah, the boxes. I don't think it's that one. Mm, I don't know.
I don't either.
All right. Well, we can come back to that one too.
Yeah, agreed. All right, 6.
Yeah, I didn't get 6, 7, or 8.
Me either. I'm so
Okay.
sorry.
No, it's all good. Okay, so a bank employs two appraisers when approving borrowers for mortgages. It is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued, which confidence interval would be most appropriate for the study.
6 properties that both appraisers have recently valued. So wouldn't this be paired?
I think so.
Because they're comparing them, or it would be, yeah, right? Because they're seeing the difference, maybe.
Yeah, I think so. I don't know. These confuse me so bad.
Yeah.
There's just so many options, so many ways to go wrong.
Right? And there's only one way to go right.
Exactly.
Okay, 7. In the Wall Street Journal article on satisfaction with career path, the percentage of psychology majors reporting they were satisfied with their career path was reported. Same data was also reported for accounting majors. You decide to construct a 95% confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate for the study? If the observed difference is significant,
Mm-hmm. It asks for confidence interval, so would it be confidence interval for 2 proportions?
it could be.
Or it could be any of the A, B, or C, or D. I just realized they all say confidence interval. Never mind. I
Yeah.
thought I had narrowed it
But
down.
but well, you kind of did because it's a two groups things. Like there's the accounting majors, and it's their the percentage of psychology majors reporting they're satisfied, and then the same thing with the accountants. And then it's you decide to construct a 95% confidence interval to see if the observed difference is significant. So it could be 2 proportions. Let me see. I just have a hard time remembering which one does what.
Yeah, me too. Yeah. I don't know.
Um,
It might be 2 proportions because it's doing it for psychology majors and for accounting majors.
right. Where is
So they're
that?
doing one thing for 2 of them.
Do you remember which lesson that was in?
I don't.
I'm just going through the summaries.
I'm not sure.
So the chi, where'd it go? Where?
Oh, a confidence interval for 1 proportion is in a lesson 17.
Okay. So lesson 18 is for 2. Okay. So it could be a confidence interval for 2 proportions.
Okay.
If the observed difference is significant. Yeah, it could be. Because for 18, it has the null hypothesis is always that they're equal. But then the alternative hypothesis can be left-tailed, right-tailed, or two-tailed. And if it's two-tailed, it means that they're not equal. And so if it's testing the level of significance, if the observed difference is significant, then it'd have to do with the p-value. I think.
All right, sounds good to me.
I don't know. But that's just what I'm going to put.
All right, so which one?
For 7, I put F.
The two proportions? Yeah. Okay.
Mm-hmm.
Sounds good to me. All right, number 8. So double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if it is a true assertion by the company who makes them. You take a sample of 55 double stuffed cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to a filling amount in regular Oreos. Which confidence interval would be most appropriate for the study? I have no clue.
I think it could be B. I'm trying to remember which one it is where you don't know.
The standard deviation? Or is that
That's where
something else?
it's where you don't know the true mean,
True
and
mean.
you're trying to
Okay.
figure it out.
So you're saying it might either be A or B?
Yeah, I think
Okay.
because it's just one group. It just says you need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos. So it's just we need to find the true mean of what's in the double stuff so that we can compare it to the regular.
Mm-hmm. Okay.
Mm-hmm. Hmm. So the T one, that's the one that says if you don't know the standard deviation, but I don't see one that says if you don't know.
Yeah, I don't either. I looked for that earlier, but
Oh, well done. Now I have no idea.
we can come back to this one too if you want to.
Yeah, sounds good.
Okay, so I kind of guessed on the next ones. I wasn't positive. So what did you put for number 9?
I just put the first one. I don't.
Okay, that's what I put too.
Yeah, I just
So
went with it. I don't know.
since we
Does
both guessed that
that's what
one,
seemed most correct?
yeah,
What'd
that's
you
what I
put?
thought too.
What'd you put for 10?
I put the second one.
Me too.
Okay, sweet. Maybe we're on the right guessing pattern here then.
Yeah, we just have the same good instinct.
And 11, I put number 3 because I thought that one made the most sense.
I was stuck
But
between 2 and 3.
I
I
wasn't
didn't
sure.
know. I didn't know which one it was between those two.
Yeah, because it says we're 95% confident that the true mean is between 10 and 20. So if they're 95% confident, figured maybe that
There's a
means that there's a
95% chance.
95% chance.
I'd have to agree.
I'm not positive, but that's just kind of the way I was
It makes
thinking.
sense. That makes sense to me because
Okay.
I knew it was either one of those two. It wasn't the first one because that's like with just a regular Z score or a Z test or whatever. And then the
Okay.
last one would have been like ANOVA or something. I don't know.
Oh, okay. Um, so 12, I wasn't positive. What'd you put for 12?
I just remember you telling me one time that the percentage that they give you is the mean. but I wasn't sure, so I just guessed the last one.
Okay, that's what I put too.
Okay.
So we'll see. And then 13, I put the third one.
The third one. How did you get that?
Okay. Oh crap, how did I get this? Okay. I think I used the formula. I've been back and forth with so many lessons, I don't even remember
Right.
what is in what lesson. Crap. Okay.
So I just plugged it in the Excel file, just kind of guessing.
Yeah.
I just used 30%, and then I plugged in 100 because it says it's 100 adults, and then it says P is 30%, but I'm not sure what that means.
Okay. Did you get an answer from it from Excel?
Well, like it said that P hat is 0.3, but the mean, where did I go? The mean of the distribution of the sample proportions. Okay, no, I don't think this is.
I can't remember how I got it. I'm pretty sure I just used the formula, but I need to find which lesson I got it from. Some of these go back really far,
Yeah.
and I can't remember. No, it's not there. Let's try. From what I remember, it was pretty simple.
Yeah, these gave me a hard time on the last test.
Yeah,
Yeah, I could not remember how to do them at all.
I know I got that answer. Like I know I plugged it in and got that answer, but I have no idea how I did it. Which isn't good because I need to know how to do it on the test tomorrow. So,
Yeah,
um,
that's the worst.
okay, no. Okay.
Do you remember where your formula came from?
I don't. That's what I'm trying to find. I'm trying to find the standard deviation formula. Um, but I have no idea where I even got it from. Like all the way back in lesson 12. But I don't even think I went back that far. Hmm. Okay, well,
Um,
I have no idea where this is.
I don't either.
I mean, we just went over this stuff not that long ago.
Yeah, just it was like right before the last test.
So maybe it's in lesson 13? Or I don't think I checked 14 and 15.
I think 15 was the last review.
Yeah, that was review. Okay, let me try 14. Because I checked 12 and 13, but I didn't see it unless I just went over it. Mm. Nope, it's not in there. Oh boy, okay. Okay. I might be getting closer.
Yeah.
Maybe.
There's an
I don't.
attachment at the bottom of the page. I don't know what this thing is. It says statistical flowchart.
Oh yeah, I
I
don't
wonder
know
if
what
that'll
that
help.
is either.
Oh, that's interesting. It's like a spider web kind of thing. It starts at a statistics test, and it says, oh, like it has 2 lines, 3 lines. One goes over to 2 quantitative variables and goes down to different things. And then one goes to categorical and then has 1 sample, 2 samples, or row and column table. That's interesting. I don't know if that would help at all.
That is interesting. Huh. Okay, well, we can skip it and try to find it later because
Okay.
I don't know. And 14 I didn't know how to do. I don't know if you got that one or not. But I've looked.
I just plugged it in, like guessing into that 1 sample or 1 proportion thing,
Okay.
and I got 0.876. I don't know if that's right or not.
Okay. If it came up in it, it's probably right. Because I don't think these have been the kind of tests that like trick you.
Yeah.
Like normally, if you an answer shows usually what it is.
Yeah.
Um,
Unless they went through and tried and plugged it in there just to thinking that someone would.
unless I did,
I don't know.
but
Either way.
it's more than I've got, so it sounds good to me.
All right.
Did you do 15 and these
15.
ones?
At 15 I tried. I plugged it in and
Okay.
it didn't give me any of those.
Okay. I got them. I
What
don't
did you get?
remember how. So I got the third one, negative 0.003. So let me see if I can plug it in now. Okay, I'm in the wrong Excel thing. Hang on.
You plugged it into an Excel
Okay.
file?
Yeah. So I'm pretty sure I plugged it into so the two proportions.
Right. Now, how did you plug
And
it in?
so the N is the dang it. Okay. Just two groups. So I'm pretty sure the sample would be 1563 and 579.
Right. That's N1 and N2.
Yeah. So N1 would be 1563 and X1 would be 61
Right.
And 2 would be 579. And x2 would be 15. Are those numbers right?
Yeah, those numbers are right.
Okay. So then, yeah, and then it gives me the confidence interval as negative 0.003 and 0.029.
I must have done it wrong. So did you put what order you put those in the boxes?
So 61, then 1563, and then 15, and then 579.
What did I do wrong? What type of test do you have? Actually, that doesn't change it at all. So never mind. I don't know why I didn't get that. Oh, because I'm looking in the wrong place. That's why. That is the
Oh,
only reason. I got the same answer. Oh my gosh.
okay, good.
Wow. 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 Oh wow. Yeah, that's what I got too.
Okay,
I was
good.
looking at the standard deviation of confidence interval.
Okay, cool.
That just answered so many questions.
But the type of test is the not equal to one.
Right.
And so it makes so I put for 16, I put number 2.
So did I.
Okay, cool. And then so 17, back to the chart, it makes it the last one for
Right.
17 and 18.
Yep.
So,
Okay, good.
okay, awesome. And then so 19, I put the second to last one.
So did I.
Okay, awesome. We're on the same page.
Yeah.
Okay, so we're good on those. So now 20.
20.
So this goes to the
Chi-square.
the chi-square. And so did you get the first one?
Yep.
And then the
And then
second to last one?
the second to the last one for.
Yeah.
Oh yeah. I had a 0. I had
Did you?
0.0866. Yeah.
Okay, let me see. Wait, what's the number that you got for
I got
21?
for 21,
Yeah.
0.08 on the chart it says 0.0866.
Oh, okay, maybe I just read it wrong then.
Yeah.
Okay, I'll take your word on that. And then, okay, I guess that changes my answer then. Wait, no, it doesn't. What'd you get for 22?
I didn't put one in because this one I'm not sure if it like changes or not. This is independent, whether or not they're independent, right?
Yeah.
So it is above, it's still above 0.05.
So I just put no, the p-value is greater than 0.05.
Right.
So that's what I put.
So 23 is where
I put the second one,
the second one.
but I guessed. I'm not positive.
I have no idea. Oh wait, yes. That's right. That's right. Because the first in these, the first one, the null hypothesis is always that they are independent.
Okay.
Right?
Yeah.
Okay.
Okay. Did you get 24 and that 24 to 30?
I got 24.
Okay.
Which
So
one?
this goes back to the one proportion.
Right.
So I plugged it in and I put the sample size is 200. And then it's saying that 50 of them outperformed. So then I
Right.
plug in 50 for X, and that
You got
gives me. Wait, what?
you have the third one? Did you get the third one? Or which one did you get? Sorry.
Wait, which are you talking about? 24?
Yeah.
Yeah. I got the third one. Sorry.
Okay, cool.
Yeah.
Perfect.
And then 25, I kind of just messed with it and plugged it in and got the second to last one, but I don't know if that's right.
Let's just plug it in.
I just kind of used the formula. So it's 1 minus 0.2 times 0.2 divided by the n. So I use 1801 and then square root the whole thing and then multiply it by 1.96 because that's the confidence interval.
Right.
And then I'm pretty sure, I think you get wait. Yeah, and then it becomes 2% because it wants to know what the n needs to be for the margin of error to be 2%
Okay.
with a 95% confidence interval. So I'm pretty sure that's right because I didn't know how else to do it. So I just kind of worked it out. I just plugged in all the answers until I found one that worked.
Sounds good to me.
So I did that. And then for 26, I put the third one
So did
because it's
I.
wanting to know what performs better. Okay, awesome.
Mhm.
And then 27, I also put the third one.
So did I, because that's the
Okay,
test for it, right?
yeah, sweet. So then it's still, I didn't get 28 and 29. It's because, so the test statistic is the Z, but it's not, that's not an option, what is in there. So I thought I'd change the null hypothesis to 0.20 because it says 20% in there. And let me see. Oh, awesome. Okay, I get an answer. Okay, 28 is 1.768.
1.768.
The
So
first
did
one.
you?
I just changed the null hypothesis because it says in 24 up top that it's 20%. So for the null hypothesis, it had it as 0.70, so I changed it to 0.20,
Right.
and then I got it.
What
So
was
then
your?
it
Did you leave your n as the? Oh
as
no, it's
200.
200. Okay.
Yeah. And then the p-value is 0.039.
Right.
And so since it's less than 0.5, right? Or be greater than.
0.05. Yes, it is less.
Okay. So then you reject it, right?
Yes, you definitely reject it.
So yes, I reject the first one, right?
The first one. That's what I put.
Okay. Awesome. So this one, did you do this one?
Kind of.
Because I was really confused on this one.
I plugged it into just a regular one sample t-test. And I
Okay.
just looked
So let
at, but I
me
don't know that that's what I'm supposed to do.
see. Probably. Um, okay. So what are we supposed to, what are the numbers supposed? Oh, okay.
So,
I remember doing this. So the random
yeah,
sample, so the n would be 100,
right. So it is two
right?
proportions. Yeah, I think it's two
Uh,
proportions.
is it two proportions?
Well, maybe.
Maybe.
I
Maybe it
don't know.
is.
Unless, are you just trying to
Um,
do it on paper?
no, I'm using the Excel thing.
Okay.
So is it for 100 blocks? The X is 300 sentences, maybe? I don't know.
I don't either. I just plugged it in there to see what the mean and everything was, but it's not asking for the mean of just his.
Yeah, it's not. Would the mean,
Well,
is the X the mean?
I
Or
don't.
no?
Let's see.
Point.
It says, assuming the requirements are satisfied, calculate a 95% confidence interval for the mean of the blue test scores.
Um,
So he wants to use this data to see if it differs from the mean blue scores of another leading translation software, which has a population mean score of 0.295
so
in
he
the data
wants to
file.
know if it's different, so it would be not equal to.
Right.
Okay. Um, so I guess I'm just not sure what to plug in for the X and the N. So I know that the N is 100 because it's the random sample.
Right.
Um, okay, well, it's not
Which
300 because I'm not even getting a number. So I think
which
it's, which what?
which Excel file are you plugging it into?
I'm using the one proportion
Okay.
because there's not like two N's and two X's.
Right.
So So I plugged in 0.295 for X and 100 for N. Oh, I think the null hypothesis needs to go back to 0.70 because that's what it normally was.
Right.
I don't think you normally change that.
It could be 0.295, I think.
Oh, would that be the mean?
The null hypothesis.
Yeah, that's what I meant.
Uh,
Because it says it's the population mean. It just changed it to 0.30.
yeah, I did.
Yeah, and I just don't know what the X would be if it's
I
not
think
0.295.
no, because the mean of his is 0.28. I plugged it into the one sample, and the mean is 0.288 on his. So it could be like 28.8. I don't know.
How'd you get the mean?
I plugged in his data into a one sample t-test, the old test that we did.
Yeah, that's where I'm at now. So what did you plug in to everything?
The only thing I plugged in was all the data from his file.
Wait. Oh, I don't have the file open. That's why. The blue test, right?
Mm-hmm.
Okay, so what am I supposed to open up exactly?
I don't even know if I was supposed to do this. I just plugged it into the one sample t-test so that I could get the mean and everything else. But I don't know what I'm supposed to do.
Okay, let me open up the blue scores
Okay.
and see. Okay. Yeah, I don't know what we're supposed to do actually. Oh. Oh yeah, okay, I know how to do this. So all it wants to know is, isn't it the mean for, oh, just kidding. No, never mind. I'm confused and lost. I'm not sure. I don't know how to do this one.
I don't either.
All right, let's skip to 35 then.
Sounds good.
We'll come back to it. So 35, I just plugged it in.
Oh, this was a difference, right?
Yeah. So I just did
A paired sample.
no, I took the mean of both of them.
Oh,
Like, so it wants to know I'm pretty sure it's finding the mean for them. I'm not positive, but because I don't know how else, I don't know how to use the other Excel file because it's just a bunch of list of numbers.
right.
So I just did equals the sum of all that row and then divided by 41. Dang it, didn't do it. Sum just divided by 41. Why is that not working? Oh, yeah, no, that should work. That's how you find the mean, right?
Yeah.
Sum of all of them. Oh, I need to do it separately. I'm gonna do that.
This is what I did. You want to just check out the screen?
Oh, I didn't even know that that was an option. Okay, hang on, let me pull mine up.
And you know how there's like 3 different files that they have for the Excel tests?
Wait, how did you find that one?
It's, let's see, it was categorical data inference or something. But anyways,
Okay.
they have three different ones, and so I downloaded all three of them, and then I click and drag on these things, and you can actually just like set them on the same Excel file, and that's what I did, and it's
Okay.
super. So I have them all right here.
All right. So
I,
the mean would be the variable 1 and variable 2, right?
uh,
Oh yeah, I actually got those same answers.
yeah, you did, but you did it the long way.
Yeah.
Then
Okay.
what was the question? 35?
Yeah. Give a 95% confidence interval for the true mean differences of height. So that's it. It's just the variable 1 and variable 2. And then the test statistic isn't that supposed to be the Z
I think it's.
or is it the T?
Is
Okay.
there a Z?
It's the Z on the other one, but I think it's the T. It is the
I
T
think.
because it says T equals in the
And
question.
then here's the confidence interval right here.
So 22.446. And confidence interval is 40.
That's D of F.
Oh, that's D of F. Just kidding. Wait, where do we need the confidence interval at?
Let me check.
Oh, I found it. That's the 1681.360, right?
No, that's the mean. The confidence interval is down below. It's 8.728 for the lower bound,
Oh, okay. That
and
makes
then
sense. And that's what it's
10
asking for, right?
yeah, on number 35.
Yeah. So 8.728 and then
10.455.
10.455. So then
Yeah.
the T is 22.446.
Yes.
And then the DF is 40.
Yes.
And p value is
It's 0.000.
already. So
Yeah.
then we reject the null, right?
Yes.
Because it's less than 0.5.
Yes.
So no, because we reject the null.
That's right.
Okay. All right. So we got that one. So we need to do 31 through 34. So that group. And then,
And then there's a couple more.
yeah. All right. Well, let's try to figure this out then. Okay. So I think we use the same thing that you had pulled up. So do
On
you
which one?
have the same Excel thing that you just used for the last one?
Yeah.
I think we use that again. So except we plug the blue scores into it this time.
Yeah.
So it'll
It's
be
just
for one proportion, right?
yeah. So yeah, one sample t-test.
Mm-hmm.
Here, we'll do this.
So if we plug those numbers in,
Back.
it should give us what we need. Relax. My goodness.
So these are the blue scores.
Yes. So confidence interval. Okay, I actually did it right. Okay, I did one of them right, sort of. Okay, so it'd be 0.282 and 0.293. Okay, and then it says that the DF is 99. And the t-test is negative 2.803. And then it wants the p-value, which is 0.006.
Right.
Okay. So it would be insufficient evidence to say it's equal to. Or say it's different?
I don't know. I don't know what they want to compare.
I think they're asking if it is different, so it might be insufficient evidence to say the true mean is different. Or, no, I don't know.
I don't either.
I actually have no idea.
I think that the null hypothesis is that it's equal to. So I would
So
have
would
to
it
say
be
it's the second one.
insufficient evidence that it's equal to?
Yeah, I would have to
Okay,
say.
that sounds good to me.
Me too.
So, okay, so let me go from the bottom up here to see what we've got. I got all that. All that. So we actually just need number 8.
Number 8.
Yeah,
Is that
I
a
think
letter one?
it is a letter one. Do you have all the other answers? I feel like maybe I have one that I had done. I just want to make sure you have all of the other ones too.
I think so. If I don't, it'll tell me before I submit it. I hope.
Oh, okay, that's good.
I hope. If it doesn't, I'll be really sad.
Yeah, that would be really sad.
Oh, okay. No, I do have 7. It's just an F, small F.
Okay,
so
I don't know exactly.
well, it could just be a regular
T-test or
or a Z,
T-compound?
even a Z.
Yeah.
I mean, I guess it could be a T2 because they don't know the standard deviation.
Mm-hmm. I really don't know though. I've never learned these.
Right.
They confuse the crap out of me. Okay.
It's not C because they just want to know or to estimate the true mean so that they compare it to the regular ones. I don't think it's B, and I don't think it's F. And I don't think it's E either because it's not really a proportion.
All right, so you think it's either A or B?
I think so. Better flip a coin. Just
Whichever one you think it might be more so, I guess we'll go with. Because I think you have a better idea than I do.
I don't know, but I'm sorry if we get it wrong.
No, it is just fine.
Let's go with A, I guess.
All right, A sounds good to me. Alrighty.
All right.
Well,
Give
let's
it damage.
see what the damage is.
3, 2, 1, go. Oh,
Well,
it could be worse,
yeah,
but not by much. Definitely wasn't A.
it's not horrible. It could have been a lot worse.
Yeah, it could have been horrible.
Man, how are those wrong?
I don't know.
My goodness.
Did we use any bacon?
Mm-hmm.
We did?
Blake used me and Blake used them for burgers. Yeah.
Well, we got 26 and 27, right? 28.
Oh man, I got a lot of these wrong. Sorry about that.
Me too, because I got a lot of. Yeah.
Alrighty. Well,
Well,
it could have been worse. It wasn't awful.
definitely could be worse. It was like 1% off of being green.
Yes.
It would have just
Oh,
been green. I
gosh.
would have been like, okay, okay.
Oh, alrighty.
Yep.
Well, best of luck
Good
on the
luck
test.
for sure.
Have a good weekend.